Embryogenesis, development of dicot and monocot embryo. After fertilization, the fertilized egg is called zygote or the oospore, which develops into embryo. The egg is in the embryo sac towards the micropylar region surrounded by synergids. It gets fertilized by fusion with the male gamete, resulting in formation of the zygote or the oospore, and this process is called as syngamy. The zygote or the oospore, before it actually enters into the process, undergoes a period of rest which may vary from few hours to few months. Generally, the zygote divides immediately after the first division of primary endosperm nucleus. Unlike gymnosperms, where early stages of development shows free nuclear divisions, the first division of zygote is always followed by wall formation, resulting in two-celled proembryo. Practically, there are no fundamental differences in early stages of development of embryo of monocot and dicots. But in later stages, there is difference between the embryo of both dicot as well as monocot plants. The development of embryo in dicots. According to Stokes, the mode of origin of four-celled proembryo and contribution made by each of these cells makes the base for the classification of the embryonal types. However, Snarf in 1929, Johansen in 1945 and Maheshwari in 1915 have recognized 5 types of embryos in dicot. These are: first one, crucifer type; second, asteroid type; third, solenoid type; fourth, caryophyllid type; fifth, chenopodioid type. So, coming to the development of dicot embryo in Capsular Bursa Pasteuris. For the first time, Hanstein in 1870 worked out the details of development of embryo in Capsular Bursa Pasteuris, a member of crucifer. Here, the oospore divides transversely, forming two cells, a terminal cell and a basal cell. The cell towards the micropylar end of the embryo sac is suspensor, and the other one makes to the embryonal cell, that is a terminal cell. The oospore divides transversely, forming two cells, namely the terminal cell and basal cell. The cells towards the micropylar end of the embryo sac is suspensor cell, that is a basal cell, and the other one makes the embryonal cell, that is a terminal cell. The terminal cell, that is the embryo cell, divides by vertical division, forming a four-celled T-shaped embryo. And the terminal cell of four-celled proembryo divides vertically at right angles to the first vertical wall, forming four cells. Now, each of the four cells divides transversely, forming octant stage, that is 8-celled stage of the embryo. Next, the inner cells divide by longitudinal and transverse division, forming peribelum beneath the dermatogen and pleurome in the central region. The cells of the peribelum gives rise to the cortex, while that of pleurome forms the stele. At the time of development of octant stage of embryo, the two basal cells divides transversely forming 6 to 10 celled filament. The suspensa, which attains its maximum development by the time embryo attains globular stage. The suspensa pushes the embryo cell down into the endosperm. The distal cell of the suspenser is much larger than the other cells and acts as haustorium. The lowermost cell of the suspenser is known as hypophysis. By further divisions, the hypophysis give rise to embryonic root and the root cap. With the continuous growth, the embryo becomes heart shape, which is made up of two primordia of cotyledons, torpedo shape and mature embryo. The mature embryo consists of a short axis and two cotyledons. Each cotyledon appear on either side of the hypocotyl. In most of the dicotyledons, the general course of embryogenesis is followed as seen in case of this Capsular, Bursa, Pasteuris. Coming to the development of monocot embryo, that is Najas. Here, in this type, the zygote or the oospore divides transversely to form an apical cell and a basal cell. And the basal cell, by further divisions, that is transverse division, produce two cells. The upper cell, by two crosswise vertical divisions, form one more layer of cell, and in this the periclinal divisions occur and an axial group of four cells is separated from the protoderm initials. One of the axial cell remains quiescent and gives rise to epicotyl, while the other three grows at a faster rate and form the cotyledon. The lower tier, by further divisions, that is transverse divisions, give rise to 5 cells. The upper one and the next to it undergo a vertical and then a transverse division, and the derivatives form the central cells of this one more layer, that is Q to N, becomes densely cytoplasmic. Then the P divides vertically but does not contribute to the completion of root cap and remains as such in mature embryo. The tier S produces 2 or 3 celled suspensor. The cells of CB does not divide further but becomes cyst-like and haustorial. It has a hypertrophied nucleus and a central vacuole. In Najas marina, Vijayaraghavan and Kapoor reported interseminal leaves in the mature embryo. This is quite common in embryos of several monocots. Thank you.